Okay, friends, let us discuss question number 7 and 8 of physics of paper 1 of JEE Advanced 2015. So, in question number 7, we are given that we are rolling two discs and they have the final linear speed. So, if I take this B and D as my reference point, so I can say that they have only kinetic energies and they have the same kinetic energy. So, if they have same final kinetic energies, which is actually their total energy, I can say that they must possess same initial energies at A and C. So, the total energy at A will be due to its motion, which is kinetic energy. Also, it will have the potential energy. Similarly, for second disk also, it will have kinetic energy and potential energy. As you know that for the rolling disk, the kinetic energy will be actually the sum of translational kinetic energy plus its rotational kinetic energy will be that can be half mv square plus half omega square. And now let's convert this I and omega in terms of m and v. We will have this half mv square as it is, then half I omega square, and for disk the I can be given as mr square divided by 2, and we can convert this angular velocity into linear velocity, that will be v divided by r, so it will become v square divided by r square, and this r square get cancelled out. So we are left with this half mv square plus 1 by 4 mv square, which actually becomes 3 by 4 mv square. Okay, so now let's now compare the energies of disk A and disk which is rolling from point C. So the disk 1 will have 3 by 4 m v1 square as its kinetic energy, then its potential energy will be mg into the height, which is actually 30, and this will be equal to the energy possessed by the second disk, which will be 3 by 4 m into v2 square plus mg into the height, which is 27 in this case. Now, as you can see, this m is common on the both side, we can cancel it, and this G27 can come on the other side, and it will become actually G into 3, and we know that G is given to us as 10. Okay, so now this equation will become then 3 by 4 V1 square plus 3 into G, which is 30, is equal to 3 by 4 V2 square. Okay, and V1 this is given to us as 3, so V1 square will be actually 9, and taking this 3 by 4 on the other side, we will have 9 plus this become 40 is equal to your V2 square. Okay, so now this V2 square we can write as 9 plus 40 as 49. So taking the square root, we will have V2 as 7 meter per second, and which will be answer to the problem. Now moving to the next question, we have to find the ratios of wavelength of the two spherical stars who are emitting black body radiations, and then we are given with the ratio of the radius and also the ratio of the powers which is emitted by them. As we know that energy emitted per unit time, or the power emitted by a black body radiation star, that can be given as power, we can write as E sigma A t raised to power 4, and we also know that for black body radiation we have lambda into T as constant, which is B, and all the symbols which I have used here have their usual meaning. So now to find the ratios, what we can do, we can take the ratio of power of star A and B, which we can write as E sigma A raised to power A t raised to power T A raised to power 4 divided by E sigma A B t raised to power B raised to power 4. This E get cancelled out, this sigma get cancelled out, and then we have A divided by AB, and we have this T A divided by T B, raised to power 4. So now to us the ratio is given in terms of radius, so we can convert this area ratio into radius ratio by RA divided by RB, and it will become square in this case. Now this TA and TB, as we know that for black body radiation the T is inversely proportional to the lambda, we can convert it and it will become lambda B divided by lambda A raised to power 4. And now putting up the values, we will have this 10 raised to power 4, which will be equal to 4 into 10 raised to power 2, which is actually 400, which is given to us, and its square. Then we have lambda B divided by lambda A raised to power 4. This 10 raised to power 2 square become 10 raised to power 4, it get cancelled out, and this 4 square is actually 16. So we will have lambda B divided by lambda A raised to power 4 is equal to 1 by 16, and taking roots on the both sides, we will have lambda B divided by lambda A is equal to 1 by 2. But to us in the question we are asked lambda A divided by lambda B, so taking reciprocal we will have 2, which will be our answer to the problem.